Hello there, I'm Ryan Chan, the CEO and founder of UpKeep. In this video, we're going to explore the critical subject of leak detection and repair, also known as LDAR. We will be focusing on the U.S. Environmental Protection Agency's regulations designed to minimize volatile organic compounds and volatile hazardous air pollutants. This is a must-watch for companies in petroleum and chemical industries. You'll uncover the 5 key elements of an effective LDAR program and get a clear understanding of what a leak is in this context. So, let's get started. LDAR is a set of regulations from the U.S. Environmental Protection Agency designed to help reduce volatile organic compounds. These regulations are particularly important for companies in the petroleum and chemical industries, who are required by law to follow strict LDAR compliance procedures. So what's the main goal of LDAR? Well, it's all about reducing and eliminating unintended emissions of liquids and gases. This is a crucial practice for plants that work with oil, gas, and chemicals. By identifying and repairing leaks, companies can enhance safety in the workplace, reduce product losses, and contribute to environmental efforts by mitigating the release of harmful substances. Now, let's get into the nitty-gritty of an LDAR program. While the specifics may vary from company to company and state to state, there are 5 key elements that all LDAR programs have in common. First, we have identifying components. Each component under the program is identified, assigned an ID, and its physical location is verified. A best practice here is to track components using a barcoding system, which can be accurately integrated with the CMMS. Second, we have leak definition. It's vital that the parameters that define a leak are clearly understood by all relevant personnel. Definitions and thresholds must be well documented and communicated across the teams. Third, we have monitoring components. Each identified component should be routinely checked for signs of leaks. The frequency of these checks, also known as the monitoring interval, should be set accordingly. Fourth, we have repairing components. If a component is found to be leaking, it should be repaired within a set amount of time. Ideally, the first repair attempt should be made within 5 days after the leak is detected. If repair work is delayed due to planned downtime, a documented explanation should be provided. And fifth, we have record keeping. All tasks and activities that are performed and scheduled are recorded. Updating the activity status on the CMMS helps to keep track of everything. But what exactly is a leak in the context of LDAR? Well, leaks that LDAR identifies can be more subtle than the household pipe leak that most of us are familiar with. Leaks that contain volatile organic compounds and volatile hazardous air pollutants involve gases that are harder to visually recognize. Because of this, LDAR uses detection instruments that are sensitive enough to measure gas concentrations in areas surrounding a component. Leaks are measured in parts per million, as most standards set limits in parts per million. A leak refers to any detection of concentration levels above a standard threshold. These thresholds can differ according to the regulation being observed, the type of component concerned, as well as the type of fluid being measured. For example, most standards set by the National Society of Professional Surveyors define leaks to be greater than 10,000 parts per million. On the other hand, the national emission standards for hazardous air pollutants commonly set leak definition standards at 500 or 1,000 parts per million. So where are leaks most commonly found? Well, some types of equipment are more prone to leaks than others. Here are 7 common sources of equipment leaks: pumps, valves, connectors, sampling connections, compressors, pressure relief devices, and open-ended lines. Now, how do we go about monitoring these leaks? The most basic method involves just the senses. Sensory inspections use sights, sounds, and smells as practical ways to detect leaks, especially those that are easily recognizable and non-hazardous. Other standard methods include the use of detection instruments like catalytic oxidation, flame ionization, and infrared absorption. These instruments are calibrated to a gas of precisely known concentration to ensure accuracy. For more sensitive measurements, newer technology allows for optical gas imaging to safely detect industrial gas concentrations. The frequency of monitoring activities varies according to regulations and component type. Frequencies or intervals are usually weekly, monthly, quarterly, and yearly. Some regulations might require shorter intervals when dealing with specific toxic compounds. A typical LDAR program would include a weekly walkthrough inspection to look out for audio, visual, or olfactory signs of leaks throughout the plant. Record keeping is a crucial part of LDAR. Results from monitoring activities directly relate to key performance indicators of your LDAR program. Keeping all this information in a repository allows you to build strategies around how to maintain or improve your performance. Record keeping includes details such as the date any leaks were detected, component details, attempts at repair, and results of any repair work. It's best to also include quality assurance and quality control inspections and audit findings. There are numerous regulations and standards for LDAR at both federal and state levels. These provide guidelines on how to carry out LDAR processes properly. While most of these are concerned with environmental protection, they also provide steps on how to perform LDAR accurately and safely. Some examples of these programs include Method 21, which offers best practices on how to determine volatile organic compound leaks, and 40 CFR 60, a comprehensive set of standards that includes subparts providing leak performance compliance standards for various industries. Companies required to comply with LDAR must establish a system to find and fix leaks in pumps, compressors, valves, and agitators. They must establish a regular preventive maintenance program to periodically check potential leak components and complete environmental reporting procedures. Implementing technology such as barcoding, RFID labeling, or associated computer systems can help track leak-prone equipment and provide a complete record of problems, repairs, and maintenance activities. The benefits of LDAR are significant. Petroleum and chemical companies can easily reduce costs, eliminate potential fines, and contribute significantly to worker safety and environmental protection through LDAR compliance programs. Industry studies show that harmful emissions can be reduced by more than 50% in many cases, and that cost savings could be upwards of $700,000 per facility. In conclusion, the main focus of LDAR is to reduce harmful emissions from plants. This is especially true for industries that produce tons of compounds and substances that are harmful to the environment and the community. More than preparing companies for government audits, implementing an LDAR program promotes a sense of safety. Thank you for watching this video on LDAR. We've covered a lot of ground, from the 5 key elements of an effective LDAR program to understanding what constitutes a leak in this context. Remember, LDAR is all about reducing and eliminating unintended emissions of harmful substances, enhancing safety, and contributing to environmental efforts. If you found this video helpful, please subscribe to our channel for more content like this. To learn more about our services and how we can help your maintenance and operations teams, visit our website at upkeep.com.